In this video we are going to discuss a topic, height and distance. It's a topic which usually, its application, it comes in most of the questions. Like if you find some value, you need to use some basic concepts of height and distance. And you will get the question of height and distance like you have to find the angle, or you have to find the distance between 2 points, you have to find the distance, I have to find the height. In that case, we use height and distance. For that, we have to memorize some basic concept of trigonometry, or we write it here, or you can look at our trigonometric basic video. So let's recall. Suppose we have theta and various value of theta like 0, pi by 3, which is equals to 30 degree, or pi by 4, 45 degree. It's 60 degree and 90 degree. And according to that, we have sin theta, cos theta and tan theta and their corresponding values at corresponding angles like 0, 1, 0. This is the whole table. Suppose we have to find the relation or formula of sin theta, cos theta and tan theta. We have a right angle triangle at 90 degree at angle B and theta at angle C. ABC is the right angle triangle. Here is perpendicular, base and hypotenuse. Sin theta is the ratio of perpendicular and hypotenuse. Cos theta is the ratio of base and hypotenuse, and tan theta is the ratio of perpendicular and base. Or we can say that you can look at this. Tan theta is the product of, is the division of, is the ratio of sin theta and cos theta. Like if I divide these two values like this, so after cancellation we get this result. So tan theta is the ratio of sin theta and cos theta. There are three more ratio also, like cosec theta, sec theta, and we have cot theta. Those are like cosec theta is the reciprocal of sin theta, sec theta is the reciprocal of cos theta, and cot theta is the reciprocal of tan theta. The values of these three are according to the table we get like a reciprocal of these values at the corresponding angles. So this is a fundamental, and let's discuss what is height and distance. In height and distance we have to focus on two main things. What are they? We have angle of elevation. What is it? Like suppose a person standing on a ground and look at the above point like this. It's a horizontal line and it's a line of sight, and this is our angle of elevation. The person is standing here and look at the above point at some angle, like, or to simplify this, like we have an eye here like this. It's a eye for to remove the confusion, or it's a first point, and another one is angle of depression. In this case the person is looking downward, like we have a horizontal line and this is our line of sight, and this is our angle of depression. It's a horizontal line and it's our line of sight, and we have a eye here, eye like this. It's a horizontal line, it's a line of sight, and we have an angle of depression like this, and the person is seeing something in downward direction like this. These are the two important points of height and distance. And with this and the trigonometry ratio, we can calculate each and every parameter which would ask in any question. Suppose take some example to clarify the points. Like suppose we have a pole. And person is standing here and he's seeing the top of the pole like this. It's the top of pole and standing like this. It's a pole. It's a line of sight. It's a horizontal line. It's RI, or we can say that the person is looking from this point to the top of the pole, and we have the height of the pole is 2 root 3 meter, and the length of its shadow is 2 meter. Like we have length of its shadow. It's a pole and it's a shadow. We have to find this angle. So what we can do, we have a perpendicular like this, we have a base like this. So we have like tan theta, which is perpendicular upon base, like pole length divided by horizontal. Or you can use any type of notation like ABC or something. So write it 2 root 3 is length and divided by 2, which is shadow length. So cancel out, we get root 3. According to table, we get root 3 at 60 degrees. So our theta angle is 60 degrees. It's a basic type of question which would ask in any type of question or exam, or as I told you, its application is mostly used in various questions. As such, there is no directly question going to ask in any examination. So let's discuss another example. Little bit complex problem. Like suppose we have this figure. I am going to give you statement after drawing. We have a point like this, and is a person standing over here, or we have Q or R is seeing the top of the tower with the angle of elevation 30 degree, and after moving 24 meter toward tower, like this is a starting point, and after moving 24 meter the angle of elevation changes and its value is 60 degrees. Like if we are moving from one point toward the tower, the angle of inclination is increasing, or when we are going away from the tower, the angle of elevation is decreasing. Same in case of angle of depression. So what is saying that we have to find the tower length, and we have these parameters. If the tower is a horizontal line and line where we have 2 line of sight. But we can do that. Suppose the length of the tower is h, and we can suggest this parameter as x. So firstly we take this triangle, and after that we are going to take this triangle. Okay. I think I should show this. Let's take this PQS triangle QRS. We have tan 60 H by X. Tan 60 is perpendicular upon base. Is a ratio perpendicular upon the horizontal line. So we have tan 60 as root 3, and we get our first relation. And in triangle PQR, what we have tan 30, the ratio of tower length divide x plus 24. By using these two equations, what we get, tan 30 is 1 by root 3, and we get this value. By using these two equations, we have two parameters like this. We have suppose use this equation like x is h by root 3, or we can say that h is equivalent to x root 3, but our main focus on tower length, so we are going to eliminate x from this equation, substitute this value, and we get like 1 root 3 h root 3 plus 24. So what we get, this root 3h s plus 24 root 3. So we get h plus 24 root 3 is equals to 3h. By cross multiplication, we get root 3 into root 3, we get 3h. So what we get is, by solving, 2h is equals to 24 root 3, and after that we get h is equals to 12 root 3. Or you can substitute the value of root 3 and calculate the exact value. This is a whole process to calculate the value. But what if I told you a trick? What if I told you a trick to find this answer in one line? Like we have, I'm going to rub this. Okay, like this. We have this. It's suppose take it's a theta 1, it's a theta 2, and it's our distance d. So to find this value h, we are going to use d is equals to h product of this value. All you need to substitute the value and you will get the answer in one line. Like this, we have d is equals to 24 and h is this. Cot theta 1, theta is 1 is 30 degree, and which is reciprocal of tan 30, and this value is 60. This value we have tan 30 is 1 by root 3, so we can write this like h, it's a 1 by root 3, so we can write it here root 3 divided by 1 by root 3. So from here we get hr root 3 meter. It's a simple trick to calculate when we have to find the value in this type of question. It's a trick for this type of question. Okay. So let's take another numerical. I'm going to rub this side so that you can look at this formula. It's a very important formula for this type of numerical. Take another example, like for angle of depression, like in this case, a person is standing on the tower and is looking for a board. When he is looking at the board is coming from this point. Suppose we have this C, and it's a A and it's a B. Is looking from the tower. Angle of depression is 30 degree. So it's a 30 degree. So by using geometric concept, this line is parallel to this, and by alternate angle we have this. This angle is changing. The board is coming from this point C, and the angle of depression is changing from 30 to 60 degree. And by using another geometric concept, we can write it here as this and name this point as D. Angle of elevation, angle of depression. These angles are angle of depression. The point I source is here. The person is standing at A point. So its position is changing from C to D. and is traveling with some speed, or and he's taking some time like 10 minutes from C to D. C to D is the boat is coming from C to D, and we have to find the time taken by boat to reach the shore from this position. We have to find this time, dv time. So what we have h, the height tower, and we have two angles. So what we can do, like this is x, this is y. We have two triangles, this triangle and this triangle. Taking one triangle at a time, we find various relation, like taking this triangle ADB, what we get, tan 60 is the ratio of h divided by y. And taking this, what we get, tan 60 is our root 3 h by y. I'm going to rub this side. Taking now the triangle ABC. Triangle ABC, what we have, tan 30 is the ratio of h divided by x plus y. Here tan 30 is 1 divided by root 3 h divided by x plus y. These are two equations, and we have three parameters. Like, so what we can do, like from here we get y is h by root 3, and from here we get h plus x root 3h. So from this what we get, like we getting our y value and x value. It's our first equation and it's our second equation. Subtract first from second, what we get, x plus y minus y root 3h minus h by root 3. From this we get the relation between h and x. What we get, x is our 2h divided by root 3. So we get this distance value. So now I am going to discuss further steps, like he is traveling this much distance in 10 minutes. Okay, in 10 minutes. As the previous, we get y as r h by root 3. So we have to find this time in which he is going from D to B. He is traveling D to B y distance. So this distance is traveling in 10 minutes. So we can write this, h by distance is traveling in 10 root 2h multiply root 3 into h by root 3. It's a unitary method, and by cancellation we get h, and we get this value as 5. So time taken is equals to 5 minutes. So from D to B, boat is going to take 5 minutes. Let's take another example. I suppose that this concept should be clear to you. So let's discuss another type of numerical. There are lots of numerical in this section, but we are going to discuss some important numerical so that everyone will get some basic knowledge, and after practice you will get more knowledge related to this topic. We have two tower, like one tower and one bigger tower, like this, and it's a distance between, or you can say that horizontal line or distance between the two towers. Like the angle of elevation, or you can say that angle of the person is standing on the toppest point, this point B, or A, it's B, it's C, or D. angle of depression, like from the foot of this small tower, is, we have two angle of depression like this, and sorry, my diagram is quite tedious, my drawing is not good. It's like this. These are two angle of depression when the person at A is looking at the top of this tower and the foot of this tower. These are like, we draw horizontal line, and it's the angle of depression for the foot, and it's the angle of depression for this. To remove this confusion, we draw a horizontal line like this. So the angle of depression are given at the top, or for the two tops are this is 30 degree and this is 60 degree. So by using geometric concept, we write it as 30 or we write it as 60. Sorry, both the angles are in reverse order. So what we have to find the width of distance between these two tower and the height of other temple. One temple is 54. The bigger one we have there, the bigger one is 54 meter, and we have to find this edge and the distance between these 2 points. Suppose it is x. We are going to rub this for calculation purpose. So what we have to do, take this triangle and this triangle. By using these triangle, we can calculate our various value. Suppose this portion is y, this portion I am going to name it as E. A is y, and so what we get, EB is 54 minus y. Okay. So let's take our first triangle, which is ADE. What we get from this, but it's a rectangle, so we get our parallel opposite sides of the rectangle are equal, so this value is also x. From triangle ABE, what we get, tan 30 is equals to y divided by x. So tan 30 is 1 by root 3 is equals to y divided by x. And from triangle ABC, what we get, tan 60 is equals to 54 divided by x. Okay, its our value is root 3 equals to 54 divided by x. So from here we get as our value 54 by root 3. By using rationalization, we get this value is equals to 18 root 3. We get x as our value. So what is our y value? By substituting this value, we get 1 by root 3 in this equation, like here. So we get 1 by root 3 is equals to y divided by 18 root 3. By cancellation root 3, we get here y is equals to 18. So our small height, which it's a triangle, so we get here from this value y as 18, y is 18, and subtracting this value, we get as our answer AC value, we get the width of this value x, we get 18 root 3, and after this we get the height of the temple. We get height of the temple is h, which is equal to opposite sides of the rectangle is equal to 54 minus y. We get 54 minus 18 as equals to 36. The height of the small tower is 36 meter. What if I told you a trick regarding this to solve this type of question in one line? Like, I'm going to rub this thing. I hope you will going to understand what I am trying to say. So name this as this whole value AB as H, and this value, these are two angles, named it as theta 1 and theta 2. We have these two angles and we have height of the big tower H, and we have to find, like, using this relation, H is equals to small h cot theta 1 minus divide cot theta 1 minus cot theta 2. By using this relation, we can calculate either height of the small tower or the bigger tower when the two angles are given. Or we are going to substitute this value as 54 is our bigger height and cot theta 1 is cot 30 and this is cot 30 minus cot 60. What we have at cot 30 is our root 3 and this is root 3 minus 1 by root 3. So we get it here as 3h 3 minus this. So this value will come by using cross multiplication. We get 54 3h divided by 2 and we cancel out it at 18. So what we get, h is equals to 36 meter. It's a solution. It's a trick. This formula is a simplified formula of all those calculations which we done previously. Let's take another case, another type of trick. Its application also you can use in various questions. As we know, height and distance is a type of geometrical thing, and in this we are using trigonometric functions. Without trigonometric function we cannot calculate the values. So suppose we have a two tower, or we can say that we have a two opposite banks of river. Like this one is watching from this point and one is watching from this point. We have d1 at this value and d2 is this value, and this is our theta 2 and this is our theta 1, angle of elevation. Or if the person is watching from this point, then we can say that various angle of depression by using like this geometrical terms I, and like this if the angle of depression are given by alternate angle, we can say that. What if we have to find the distance between these 2 points? It's a trick for special purpose. Like when we have theta 1 plus theta 2 is equals to 90 degree, then in that case the difference, the distance between these 2 points is equals to the square root of the product of d1 and d2, both the heights. It's a special trick. It is applicable only when theta 1 plus theta 2 is equals to 90 degree. It's all about the height and distance. By doing practice, I think you guys will be going to be an expert in this topic. As I told you, there may be less chances of direct question related to height and distance, but you can use this concept in various questions, or I can make various questions by using this concept. I hope you will understand what we taught. Subscribe our channel for more updates or related tricks or various other lectures.